All right, thank you for joining us today. We're here with WinBidPro webinar, another webinar of ours, and we're going to talk about silicone glazed systems, and also known as SSG, structural silicone glazed. And GDS doesn't have a specific way to deal with glass in these systems, so there's a couple things that you need to do to get things to come out correctly. And there's a couple other things to keep in mind as well. The structural system, the silicone glaze systems are a little unique because the fact that a vertical joint in the intermediates are silicone, and there are times and many times when there's a back member that is an extruded stock length of aluminum. So the program can't draw both things right now. What I think what we're eventually going to have it do is draw the little dashed line that's, you know, an inch or half inch or whatever that gap for the silicone needs to be. We'll have to draw that as a dash line on top of the verticals so that you know that, or actually it would be the verticals are the dash lines and the 3/4 inch or half inch joint is a solid line, because that would show you the exterior silicone joint for the glass, and then the dashed lines would be the backside structural members. So it's a little tricky. So if you don't know, we're working on a version 16 program right now. So we are planning on making that possible in that version. So the functionality should be there for that. In addition, we have the issues of trying to get the glass sizes correct, because if you have a glass pocket on the perimeter and then your silicone joints on the interior, the program needs to know what values, I guess, to use for measuring the glass width and height. So right now, the program sees these vertical mullions and basically takes a daylight opening, like right here, and it says, okay, this is my daylight opening for the glass, and then it looks at our framing system and says, what's our add to daylight? So we look at our framing system here, and we're in an FCO catalog. I've picked a 2.5 by 6 curtain wall system that's a structural glazed system from FCO. And this, where was I going? Oh, so this has a 1 7/8, it looks like, or what is that, 875? Yeah, anyway, let's say that's 1 7/8. Let me get my little calculator out here. That'll be a good check for us. Yeah, 875. So 1 7/8 added daylight. So that's overall for the vertical height and overall for the horizontal height. So it sounds like the way this system is set up, it's accounting for, I'm going to go ahead and close this. It's accounting for the silicone joint in the middle. So it's kind of giving it more glass than it normally would have if it were just a regular framed, aluminum framed elevation. So the problem is you've got a little too much added daylight, and that means your glass sizes might be a little too big when it comes to the perimeters. So if we had 2 rows of horizontals, like let's go do this. If we go to the horizontals and let's say I delete that one and I add a new one at say 32, oops, and I add another one at say 64, no, let's say 70. So I add another row of horizontals. So now if we have these pieces of glass on both sides of these 3 pieces here, there's going to be a silicone joint, so left and right. So the width is going to be correct based on our added daylight, but the height is still going to be, well, it depends on whether there's a cover plate or not. So that's another thing we'll talk about, is all the different configurations of silicone systems. So this particular system is set up with no covers, outside covers. So it's basically silicone joint horizontals and verticals, and there's a little setting block chair that the horizontal light's set on. But in some cases, a curtain wall will have pressure plates and it'll have a face cover, and then only the vertical joints are silicone. So in that case, your heights would not be correct. So there would be some tweaking, and when we do eventually get this to work without any tweaking, we have to take into account all those different types of systems. So it's a little bit tricky just because of the variety with silicone systems. So in this case, we're assuming just by virtue of what system I've selected in EFCO's catalog. Let's go into that system. We're looking at their system. I'm going to look at a detail just so it helps us, see what's going on with this system. So the head pieces are held in place with clips, and here's our glass right here. And there's some rope and a silicone bead, and then there's a stop. And this stop on this particular system actually covers the perimeter. So the jambs, the head, and the sill all get this stop. And this stop is applied with a screw, and then there's a snap cover to fill it. So in this case, we've got our silicone structural sealant here, and then we've got a clip holding the member in place, the back member. So you'll notice there's the same thing. Like, let's go to a horizontal. Same thing here. So it clips to the verticals and the jambs, and we've got. This is kind of a strange detail drawing. It gives us nice dimensioning here, but it doesn't give us this dimension, which is a 6-inch depth. The problem is they're showing these green lines, so it makes it a little tricky to look at. So pretend like these green lines are dimension lines, and these green lines here in this rectangle are glass. So we've got our silicone bead, we've got a strip of vinyl here, and we've got our setting block chair right here to hold the glass up. So again, we've got a silicone joint here on the horizontal joint, and we've also got it on the back to secure the glass. So now let's go to, say, a wall jamb. Now our wall jamb has that glass stop. This is kind of throwing me off. Oh yeah, this is a left jamb. So I guess some of the manufacturers will actually give you a left jamb detail and a right jamb detail, and some will just show you a jamb. So you have to kind of flip it for left and right. But EFCO's got a pretty good set of details here. The one exception is this depth here of 6 inches. But anyway, so we've got the same stop on the perimeter for the jamb. We've got the rope with the silicone and the silicone structural sealant in the back. And so this is something that our drawing is not showing, actually. So our drawing, like if we go back to it, that little glass stop or that frame stop, it's not really holding the glass, but that frame stop is actually around the entire perimeter, right? So we're not showing that as being continuous on the drawing. So there's a couple things we can do. If we want that to show continuous, then I would have to change these dimensions a little bit. So let's say that's a 1/2 inch stop. And it's up there at the top of the perimeter. So I would have to say that my head is actually 2 inches. And then my stop, which is treated like head can because it's a continuous piece, is a 1/2 inch. And then the same thing would go for the sill. And then this would be 0.5, and I don't want that to be 5, I want that 0.5. So it's a little tough. We can't do it on the jambs because we never really planned on, they're continuous anyway, so we never really planned on drawing a 2-piece jamb. But in this case, this is what it's going to show us. So let's redraw our elevation. Now it's a little tough because it's a fairly big elevation, but it does show. That would be that glass stop piece. Now we could actually make it a little bigger if we wanted. And then the overall profile is still 2.5 what we wanted. But if we wanted that stop more visible, I could actually make it 3/4. And then we could make this 1 3/4 inches. So I'm just kind of playing around, but actually there was a dimension on that drawing that we can use, but this is more for looks right now. So let's do this, and then I'll show you the difference here. So when we hit OK, and remember that sometimes it doesn't redraw completely, right away. So sometimes you have to hit redraw, but it looks like it did for us the first time. So it doesn't hurt to hit redraw more than once. So this is a little more true to what it's showing. The difference is these head pieces here, the filler pieces, they're in between the verticals and the jambs. Those should be dashed. So technically they're behind the glass and you're not seeing them from the front. So you're seeing them through the glass. But that's something we'll have to work on in version 16 as well. So, but this way, it kind of gives you a better look, but it also changes the cutting. So that's something else to think about when we're playing around with the looks of a drawing. So as I mentioned earlier, the way we're doing this now is we're drawing it with the vertical mullions, which are actually behind the glass, but we're drawing it so it shows those. The reason we're doing that is so everything gets cut correctly. So these horizontal pieces here, this is a true cut size because these back members are actually 2.5-inch profile. So we're going to get the correct horizontal cut sizes if we do this. Now, if we were to say, I want to see the glass joint so that it looks more like a butt joint on the front, side of the elevation, so from face on, then I could change my vertical profiles so that it's 1/2 inch or whatever that is. So let's go back into the elevation drawing here, or I mean the detail. So if we look at the detail of, say, the horizontal, it's giving us a 5/8 joint. So if it's a 5/8 there, let's see what it is for a vertical. It's probably 5/8. It should be consistent. Yeah, so 5/8 joint on the verticals and the horizontals. So in that case, I could actually jump over here and say that my verticals are 5/8 of an inch, right? What is that, 675? Oops, I clicked away. 0.675. So if we do it that way, we're going to get more, or I'm sorry, wait, so 5/8. Yeah, 625. I don't know what I'm thinking here. So if we do it this way, we're getting the look of the joints on the, let's say we want to do it for the horizontal since those are actually 0.625 also. We're getting the look. We're also getting more accurately the, see, this time it didn't redraw, of course, so we're going to do it again. That time it did. Why didn't it do our horizontals? Let's go back to horizontals. Horizontal 0.625. That's interesting. It's not like in 625 for the horizontal. That's funny. I wonder if I have to remove them. Oh, you know what? That's kind of a weird glitch. So keep that in mind. The problem is we store the horizontal profiles, and the reason for that is because we have multiple horizontals. So I could have actually changed it right here for that first, I already deleted one, but I could change it for the one that's left. So now I can add in that 32-inch one. And it's going to go back to the framing system and pick up the standard horizontal. And I could have even been playing around even differently. I could have said back to the framing system. I could have created a, oops, I could have created a horizontal 2 that is silicone. I think I spelled that right. Yeah. And we're going to add that part because it's not in this catalog yet. And we're going to, if I want to say silicone is like a stock length, then I would want to come up with a price that is, and I can actually put it under mill or other, come up with a price that's kind of like a stock length. So let's say a tube of silicone does 20 feet, oops, 20 feet, and it's a tube is, $9. So I would say it's 20 feet, 244, right? And this is a tube of 3M silicone. So I could kind of get my price based on that, and I could actually say, let's see, what do I have? I guess I'd want to call it a stock length anyway. I'd want to call it stock because I'm entering it into a stock length field in the framing system. So the program's actually going to treat this like stock. So it's going to call it silicone. I could actually change this vertical part to silicone. And notice how I type it in lowercase and it converts it for me. So you don't have to worry about doing caps lock or any of that stuff. So now I could do this. I could say it's a horizontal 2 is my silicone, and my horizontal 2 profile is the 0.625. And then I could say, my regular horizontal is still 2.5, so I could kind of do both. I don't have to have one or the other. So that's the point of having a horizontal 2 compared to a regular horizontal. So now, if I go to my horizontal window, I could say, I don't want this one anymore. I want to put in a new horizontal, and I'm going to say it's a horizontal 2, and I'm going to put that one at 65 inches. So it's going to draw out the profile that I configured in the framing system, and that way I could actually mix and match. I could have a standard horizontal, I could have a skinny, tall, whatever. So this is more like the elevation would look, except for the little stop material on the sides isn't really visible. But the problem with this is the head and sill filler pieces, and the horizontals for that matter, are all going to be cut wrong because they are thinking that they're cutting in between a daylight that has a 5/8 gap of mullions. So right away we would have to adjust our cut sizes. Now we could do that. If we adjust our cut sizes, we could go back to the framing system and we could say, now the problem with this is that you have the same problem you have with glass. Since we're not drawing this profile here as the 5/8, then we're not going to see the right dimensions. So again, it'd be easy to say that this horizontal piece is extended, an inch too far on each side. So we'd have to say we need this less 2 inches. Now we can do that in the stock length tab for all the horizontal material, and same thing for this. The problem is, yeah, you have to have the other part number too. So where's our regular part number? It gets a little screwy for sure. If I wanted to say that I needed a silicone and the other part numbers, because if I didn't do this right here, if I didn't copy and paste these part numbers in here, the only part number for a horizontal 2 it would have picked up is silicone. So if I needed to do the silicone and the back member, I have to make sure all the parts are there. So the difference here is, the only difference is it's going to draw horizontal 2 as a 5/8, but it's still going to price the stock length back members and the silicone sealant for the joint. So a little tricky. So we're not going to mess with the silicone joint sealant. I guess we could. No, we're not, because that's going to be the actual width of whatever we're drawing here because of the smaller gaps. So for the actual components though, since those are behind the glass and those are getting interrupted by verticals that are also 2.5 inches, let's say that these need to be 2 inches shorter. So I would have to put a minus or a less than 2 after each part number that I need to be affected like that. So if we were to go and say, optimize this elevation now, let's do that. Let's optimize this elevation. We're going to get the parts. Now before I actually optimize, which I actually don't need to do because I'm not worried about stock length counts right now, the only thing I'm worried about is what sizes the cut pieces are. So our horizontal daylights are 38.5. We can see that right here. So we've got 38.5 based on a silicone joint, but we know that our back members are going to be different because they've got the 2.5 inch material running up verticals and the horizontals. So we've got horizontal 2s here, and where's our part number? There's our silicone's going to be down at the bottom because it's text, and these are all numeric. So we're not going to worry about the silicone sizes. Those are just there for pricing. What we are going to worry about is these sizes. So we're showing that it's 2 inches less. This is why I was taking you here. So our daylight here is 38.5, but our cut size is 36.5, and that's because I put that less than 2 inches after each part number for the horizontals. Now notice though that the sill and the head material, it's funny how it's sorted that, isn't it? Let's sort it by part type. There we go. So when we sort it by part type, then it throws in the silicone, but whatever. So, okay, so our sill and head material is actually going to be the 38.5, which is the true daylight based on the drawing, and that is because I didn't go ahead and put the less than into the after the part numbers. So if I really wanted to mess with all the sill, the head, the horizontals, draw it this way, and then have the program cut everything, I would have to go ahead and say, sorry, for these sill members, I would have to say less than 2 inches. Now, again, the problem with that is it's going to be great for all these intermediate pieces that have silicone on both sides, but for the members that don't, it's going to be the wrong size. So you can't really rely on that -2 because one side needs to be subtracted, but the other side is correct because it has the full width profile there. Now we could go ahead and account for this by changing the profiles of the jambs. So let's say our left jamb needs to be it's got that little stop. Let's go ahead and take a look at that left jamb detail again. So we've got a 15/16 stop and a 5/8. So we got that. Let's see what that is. So 5/8 is the 0.625, and 15/16 is 0.9375. So we get that. Oops. Let's see. Well, let's just call this correct. I might have messed up, but it's 1.875, let's say. We need the profile of the side stop here with the silicone joint. And that's what would give us the correct glass sizes. So let's say we change our jambs to 1.875. Here we are right here. 75, and I'm going to do it for this one. So this is going to give us more accurately. Now let's go ahead and say that's the head and sill too. If we want that continuous look, 0.1, 2, 1.875, I said, right? Well, let's go ahead and call it, so the head and sill, oh, actually that was 15/16. This is really confusing. Yeah, 15/16 was that little stop material, and that's continuous. So that was the 15/16. That was what we want to show up as our head and sill can material. So 0.9375. But you guys get the idea, 0.937. Without being exact here, let's just say this is 1 inch. And this is 1 inch. And the main thing here is I want to show you what the look is. So this is accounting for the stop material and the, or the strip or whatever you want to call that, and the silicone joint on the perimeter. So this way, we're going to get the correct, okay, so yeah, we must have this right. Now sometimes what I like to do, this is kind of a trick, is I like to use the distance tool, and just to see if I've got, if the drawing's correct, I click that and I click over here. Now this one's, the problem with this is it's tough to get it exact, but I know that I'm pretty close. I know it's not 2.5, right? So I use that just as a double check to And it helps more too if you zoom in more. Like let's say I zoom in here really tight, and then I use the distance tool. It's a little easier to get it. My mouse is a little touchy too, so you know it's a little better to click on it and get a more accurate measurement if you're zoomed in so much. So then we can go back out to 100% easily. Okay, so this is kind of the true measurement, I guess, of the glass. So in this case, we don't have to mess with our glass because we've got the joint sizes are correct all around, really. We've got our head and sill and our perimeters set so that the member showing here is actually to the edge of the glass. So in this case, our glass sizes will be correct. Our cut sizes, we just have to go in and do the adjusting for the intermediates. So let's see. Now the verticals, let's say we had to adjust those. This is, again, getting a little more finagling than we really need to, but so let's say the verticals go all the way through, and right now we're deducting the cuts for the verticals by the profiles of this head cannon subsill. So if the verticals need to go all the way through, we're basically going to add just shy of 2 inches to the verticals. So I would have to go here. Oh, I took out that part number, which I shouldn't have done, but let's just call it one of these. So I would have to say on the vertical part number, I would say I need, I don't know, let's just call it 1.875. And so I'm adding to that so that it actually does go through, because that other perimeter strip is going to cover the joint of the vertical and the back fillers. So it's kind of the same thing with can systems. You've got one thing that's continuous and the vertical needs to sit up inside it. Now there's one other way I can mess with this. I could say, instead of adding to each part number that length, I could not do that. And I could go over back to the framing system here, and I could say I need this to, I could say add me 1.875 here, and that's going to add that length to every vertical mullion. So it's a simple way of doing it. Now the difference is, and you'll see this, is that it's going to cut it. Did I do it too much? Anyway, it's going to give you kind of a what you see is what you get thing. So it's cutting it so that it runs through, because that's actually what we're wanting it to do. So the cut shows it running through the head, whoops, and the, let me go back to 100%. And then the reason it's kind of sticking up above is because we're showing an 1/8 inch gap down here, but because it thinks there's a subsill that it has to sit on top of, but in actuality there's not. So we know our measurement's right. It's showing it as running through here. It's showing it as running through the head. And we know we're going to get the right cut size. The problem is, if you don't want it to show that way, you don't want to do this. So you'd want to do the opposite. You'd want to zero this out. You'd want to go back to the stock length. And then you'd want to say, I need this greater than that amount. So 1 7/8 or whatever that is. So we're manipulating the cut sizes that the drawing itself is not giving us what we want. So that's a way to do the verticals. I would actually have to do it on the jambs too. So I'd have to say the same exact thing. And again, you'd want to have to do the math yourself to figure out what the actual cut size you need is. So that's the kind of headache of doing it this way. You're having to figure out the cut sizes. You're having to enter the values for each piece. And then it's going to figure it for you. So our horizontals are going to be good because we've drawn the elevations so that the joints are all based on the true silicone joint sizes. Now, yeah, the problem is we're not seeing it as you would see the frame members from the back. You're seeing it as more or less as you would see it from the front. The difference is this little joint here, there's actually would be a line here between the silicone and the actual, that little strip, kind of like we're seeing with the head and sill. So that would get you the right cut sizes and the right glass sizes without having to draw it with the back members and everything else. So let's do this. Let's copy this elevation. I'm going to go over to elevations here, and I'm going to say copy this one. And oh, I have to hit edit settings. I'm going to change the name here. Let's call this one back member drawing. And then we're going to change it back. So we're actually running out of time here. I apologize. This is kind of a little trickier than what meets the eye. But if I wanted to go back to the way it was and just say that it's 2.5 everywhere, right? Oh, except not the head can, sorry. We're going to say there's no head can. It's just 2.5, 0 there. This is the way that it would actually, so 2.5 everywhere, right? This is the way that it's actually going to cut all the material correctly. Oops. So if I do something like that, sorry, I have to make sure that I don't have all these values here. And then I wouldn't have, you could actually still have your silicone part in there, you're just not showing it that way on the drawing. So you could still account for it in your part numbers easily for both verticals and horizontals. And now another way to do the silicone, if it's actually going around the circumference or the perimeter of every piece of glass, let's do that. So I took out all the greater than stuffs because the way I'm doing it now is it's going to actually draw it based on the, now remember the horizontals kind of keep their own setting, so I can still change those just by going 2.5 here. And okay, so oh, the thing I was going to say is if there's silicone really surrounding every piece of glass, which there is in this case, you treat it like gasket material. So we can actually go back to our elevation drawing. I mean, I'm framing system, I'm sorry. We go back to there and we actually just say there's silicone here. Oops, if I spell it correctly. So that's another way. Now the problem with that is we called it stock length, didn't we? So we're going to go in and fool the system a little bit. I'm going to right click as if I'm going to add a different part. I'm going to look up silicone and then I'm going to edit it. So we could actually call it something else. Let's do that. That's a little smarter. Silicone seal. And it's going to convert that, say, yeah, it's not found. So this time I'm going to add it, and this time I'm actually going to say it's so much per foot. So this is where you say I get 20 feet out of a tube. It's $10 a foot. So, I mean, I'm sorry, it's $10 a tube, and so that means it's 50 cents a foot. So we're going to call it that, and we're going to call it glazing tape just for, we could call it gasket, doesn't matter. Or we could still call it silicone actually. And then we could say sealant for silicone joints. So we call it that. There's no stock length because it's not treated like that. Now silicone, that part type, it knows that it's going to do that by the foot. So we don't have to mess with anything like that. Oh, sorry. We do have to mess with something. Let's right click again. We're going to go back and edit the one we just did. We have to tell it how many feet per tube, which is kind of like a package quantity. So it was 20, right? Because we gave it that by the foot price in this case. The other one we gave it by the tube price, which is treated like a stock length. In this case, we're treating it like gasket. So we have to tell it how many feet of gasket is there. So we're saying there's 20 feet per tube, and then we get 50 cents a foot, so it multiplies it by 20, gets you your tube price based on that. Okay, so we edited that so we don't have to like delete the part or put it back in or anything like that. We can just change it in the parts list and then it'll pick it up. So if we don't, there's another good point. There's a tool in here. So something I just realized, I added the part to the framing system, it created a copy of it, and then I went back and edited the master. So when I was right-clicking in there, I was actually editing the master list, so it didn't edit the parts list for this job. So now what I need to do, I've done all these tweaks. I need to apply the changes that I made to that part to this job. And let's say I've done it for a few different parts. I can actually say, update parts for current job. So when I do that, it's going to take all the parts that this job uses, look in the master parts list, and pull the prices and descriptions and stock links and package quantities over so that it knows whatever changes were made to the master are now applied to this job. So that's something to keep in mind. Okay, so again, I'm going to just be about 5 more minutes. So we drew this one so that we're basing it on back members. Our glass sizes we know aren't going to be correct now because we've got, well, you know what's not true about that actually is in this situation, since we've got a silicone joint around the entire perimeter of the glass, we can get the glass sizes correct. So that's not the issue with this system. But let's pretend like there wasn't silicone all around. Let's pretend like there's just silicone joints on the vertical mullions, right? So there's no silicone joints on the horizontals. There's no silicone joints on the jambs, head and sill. It's just the vertical mullions. In that case, we've got glass pockets on the sides, and we've got glass that actually needs to extend more over these verticals, right? So that you're getting to the silicone joint. So, and it might extend further into these verticals than it would if it was not a, if it's an actual silicone joint, you might need a little more glass. So what we have to do in that case, and we didn't even add glass yet, so let's do that. Real quick, we'll just add it for the elevation. So I've got my glass added for the elevation. So now what we have to do is go back to our jobs menu. Now we're going to actually edit the glass sizes. And we can do that by going to jobs, going up to here to update utilities and say job glass info. Now, before we do that, if you don't have 2 screens on your computer, we're going to want to move this one out of the way a little. Yeah, this one won't let me make it smaller. So I'm just going to push it down here so I have a view of this. I want to be able to see my drawing so I can show you what we're doing here. So I'm going to go to edit job glass. Now I can move this window around. So you'll notice I have the glass labels showing. If you don't remember where that is, it's under drawing settings. It's kind of in the top right corner of drawing settings. You can tell it to show glass labels. And that's what I'm doing here. Now, this is a little confusing because our glass show label, the one that actually tells you whether it's tempered, annealed, or whatever you want it to say, is this other kind of label. So those always show. You can't turn those off. But these glass labels for positioning the glass, you can actually turn on and off. And that's actually what we're seeing here in this list. Now, you'll notice everything on this first row has a #1. So G is for glass. The first number is for the panel. So remember, we've got our panel numbers here. So G1 is the 1, G2 is the 2, G3 is the 3. So first number is the panel, second number is the row. So if I wanted, say, all of my glass in this panel 2 to be changed, I would filter my list to G2. So I've got 3 pieces of glass in panel 2. If I know that those pieces of glass need to grow by, say, ½ an inch so that they can extend over to size properly for the silicone vertical mullion joint, I'm going to say change glass sizes, and it's only going to change what we're looking at here. And I'm going to say the width needs to be a positive 0.5 bigger. And then you'll notice that we just changed our width there. Now the trick here is you actually have to go do it for each row that needs this. Oops. So I'm going to say now we need to do it for G3. So I would do the exact same thing, and I'm going to update the glass width. And if I had to do it for G4, then same thing. So you get the idea. So that's what we can do. Now I can also say same thing if it were And that's by panel. So if I needed to do a certain row, I could say, let's say that middle row, if there was, for some reason, I need to change the size of that middle row, I could just say pound 2, and that shows me all the glass in the middle row. That's 5 pieces of glass. I've got 5 here. I could say I need to add to the height of that 0.5. Or I could say, let's say I need to subtract. I would just say negative 0.5. Now, where's our height? Here's our height. It's 32 and 375 now. We're going to see that reduce. So that reduced a lot. What did I change it to? Anyway, so if we need to change it again, let's say I need to add 2 inches to it. Then you see it was 27 before, now it's 29. So that's basically the tool that gives you the ability to adjust glass sizes in bulk. And what we're doing first is we're filtering. And if you don't want it to affect, you'll notice how it says panel glass here. If I had a door in there, there'd be door glass, transom glass, things like that. So you can just use panel as a filter also if you only want it to affect panel glass and so forth. So you can also just change it individually. If I click on here and put a number in, it's going to change that piece of glass to that number. So if I had multiple elevations and I need to change them, then you can filter by the elevation name, and it's only going to show you those elevation glass parts. So that's kind of how all that works. It's a little bit laborsome, but it does give you the power to tweak glass either in groups or individually. So that glass remains the same. Nothing's going to affect it until something in the elevation changes, like if you widen it, shrink it, whatever, or if you delete panels, add panels, add a door, things like that. Whatever changes the daylight opening, that's going to affect the glass. Now, the program will actually do its own calculations sometimes when things change, but my advice is wait until you win the job and you have to actually get the glass cut before you make all these final adjustments, and all your final dimensions are in and everything. So that's when you want to go in and really tweak the glass, because for block size pricing, you're okay just leaving it kind of the way it is, but especially for estimating. But if you want to get down to nitty gritty, then you can go in and you can edit those glass sizes and they'll keep. And that's what'll print out on your final glass report. So when we go to final glass, we'll see whatever sizes, here's that 36 that I put in. So that's how it works. So kind of in summary, I didn't have to hit redraw. There's a lot of different ways to do silicone systems. One way you have to just decide on is, do you want to draw it so that the back members are getting cut easily, or do you want to draw it so the glass is getting cut easily? And then you end up adjusting one thing or another. You either adjust the cut sizes of your back members or your perimeter material, or you're adjusting the glass. So I wish it were easier for you right now, but this dilemma is something we're going to take care of in version 16. So version 16 is probably over a year away, I'm afraid. So in the meantime, we're working on our Cloud GDS software, and we're doing that in chunks. So as one chunk is released, you'll be able to see it, because right now Cloud GDS is basically a cut list program that optimizes cut pieces. So later you'll be able to start drawing things in it. You'll be able to start putting glass in. So all those different phases are coming in the cloud. But with a desktop program like WinBidPro, version 16 of WinBidPro can't be released until it's done. So like I say, it's over a year away for that, but it is coming. So I appreciate you all staying with me. This was a long one, but hopefully you guys got something out of it. And